In this video I want to talk about how to solve system of equations word problems. And there's typically some common types of problems you might run up against, and this won't be a across the board way to solve any systems problem, but many times systems of equations word problems fall into two categories. Okay, a lot of times you'll deal with totaling something up or comparing two variables. What I'm going to focus on in this video is when you're totaling things up. So a lot of times in a systems of equations word problem, you'll see something like something plus something else gives you a total of something. And if you set up a equation that looks a little bit like standard form, it doesn't have to be an official standard form, but your x and your y will end up on the same side, equal to some sort of total. Okay. So what I want to do is take you through two examples today. So let's go ahead and flip to it. So we've got Joe and Mark are buying pizza and wings. Mark orders 5 wings and 3 slices of pizza, and his total comes out to be $6.40. Joe orders 9 wings and 4 slices of pizza, and his total works out to be $9.91. After they order, Joe and Mark are wondering how much they paid for an individual wing or an individual slice of pizza, and if they got ripped off. So to begin these types of problems, always a good idea to write what I call a let statement, and a let statement just defines your variables. Okay, other teachers have different ways of referring to this. I'll use what's called a let statement here. So what we'll do is we're going to always let our variables be what we're solving for. In this case, I'll use x and y. You really can use whatever you want. If I want to use different letters to represent what we're talking about, we can do that. But I'm going to let x be, and again, it's what we're looking for, what numbers we're trying to find. In this case, if you read the bottom, it says they are wondering how much they paid for an individual wing or an individual slice of pizza. So we'll let x equal the cost of one wing, and we'll let y equal the cost of one pizza slice. And now from this point, it's going to be a lot easier to set up because we understand what we're solving for. I know that at the end, when I get x and y, x is the cost of a wing, y is the cost of a slice of pizza. Do not skip this step. It's very, very important, and it helps you if you're having trouble. So let's now go back. We know that the wings are x, and the slices of pizza are y, and we're looking for some sort of total here in these equations, which it says the total comes out to be $6.40. So when I see that total, a lot of times what I'm going to do is just set something equal to $6.40. Okay, so to set this up, we've got 5 wings, so 5 times the cost of each wing plus 3 times the cost of each slice of pizza should equal $6.40. That's a pretty good setup here. So the money from the wings plus the money from the pizza should equal the total money. Next one, we've got Joe's equation here. So Joe orders 9 wings and 4 slices of pizza, and his total works out to be $9.91. Again, if you're totally stuck and you see the word total, not a bad idea to just set that equal to something, and then you got to figure out what you need to do with your x's and y's to make it equal $9.91. And in this case, this is a very similar equation. It'll be 9x plus 4y equals $9.91. And now from here, we're set up to solve that using elimination or substitution. Okay, so if we're solving this, probably the easier way to solve this would be to cancel out the y's. I'm going to use elimination here. You could use substitution. I don't know why you would, but it's possible to use both in any scenario. So let's go ahead and start by multiplying the top equation by -4, and I'll multiply the bottom one by 3. I'm going to try and get a -12 and a positive 12 here for both of my equations so I can cancel the y's. So this is -20x minus 12y is equal to, if we take 6.4 times 4, that should give us $25.60, and that should be negative because we are dealing with -4. Over here we've got 3 times 9x should be 27x plus 12y is equal to, we need 991 times 3, which gives me 2973. Okay, now what I'm going to do is just add the equations up just like before when we were doing elimination, And if we notice here, we get 7x. And what I want to happen is that the y's cancel. And that's important so that now I'm down to one variable. So we take 973 minus 2560 should equal $4.13. And finally, I should end this problem by dividing by 7 on both sides. And if we divide here for 13 divided by 7, gives me 59 cents. Okay. Now, again, if you weren't sure what that number meant, we can go back to our let statement, and we know that x represents the cost of one wing. So what we figured out so far is that the cost right now is 59 cents per wing. Okay, so we know that the cost right now is 59 cents per wing. We now need to find the y to plug it back in. So let's go ahead and do that too. Now that we've got the x, I think that it doesn't really matter. The bottom or the top equation is probably easier. So I'll take 5 times that 59 cents. I'll plug in here in a second. Equals 640. So I'm just going to take this 59 cents and plug it right in here for x. So we're going to take 5 times 0.59 and come up with 295 plus 3y is equal to 640. We're now going to subtract that over to the other side. So we'll take that 295 over to the other side and get 345. So that gives me 3y is equal to 345. And then finally, if we divide by 3 on both sides, we should be getting that y is equal to $1.15. Okay, which means that the cost for a slice of pizza is $1.15 per slice of pizza. And now I really don't, and this is teacher preference, I really don't like ordered pairs here. This is a much better answer, and than writing like 0.59 comma 1.15. That really doesn't explain or show that you understand what you're dealing with here. This answer shows you that you said, okay, it's 59 cents per wing and $1.15 per slice of pizza. That answer is a little bit more descriptive than the other one. So depending on what your teacher wants, give them what they want. But really, if you're a student taking the Keystones in Pennsylvania or a standardized test that really makes you understand this stuff, you really should not be stopping at 0.59 and 115. You should be writing out what these represent. Okay, we're going to go to one more. Another one dealing with two totals. So Tyler and Pearl went on a 20-kilometer bike ride that lasted 3 hours. Because of the steep hills on the ride, they had to walk for most of the trip. Their walking speed was 14 kilometers per hour. Their riding speed was 12 kilometers per hour. How much time did they spend walking? Okay, so once again, we're going to start here with a let statement. We're going to let x equal something. We're going to let y equal something. And in this case, there's kind of two things going on. They're only asking us really for one of these things. But we're looking at the time that they spent walking. And we're also looking at the time spent riding on their bikes. Okay, so we've got the time walking and the time spent riding. Now, again, when we're totaling things up, our equations should look something like this, where on the other side of the equal sign, this is what our total is. Okay, so I'm going to look through here, and I see actually two totals right off the bat. 20 kilometers was the total distance of the ride, and the total time that they took lasted 3 hours. So the first thing I'm going to do is I'm going to set something equal to 20 kilometers and something equal to 3 hours. Okay, these are the two totals that I'm dealing with here. Now, if you think about it, if we wanted to write our distance here, if they walked for 4 kilometers per hour and they biked for 12 kilometers per hour, then we could write this as an equation, 4x. That would give us the total time riding. This is almost like a d equals rt. The rate times the time should give us the distance for the one. And then the 12y should give us the distance for the other. So 4x plus 12y is equal to 20. Again, you don't have to use x and y. You can use whatever letters you want. I'm just doing that for the purists out there that always like their x's and y's. And then we've got our 3 over here. This one's a little trickier. the total time lasted 3 hours. And I don't really see any other numbers left in the equation, but if you noticed here, we had kilometers plus kilometers equals kilometers. Here we have hours. We're going to need some way to represent hours plus hours equals hours. And if we actually look back at the let statement, the time is what the let statement dealt with. So all this is going to be is that the time spent walking plus the time spent riding should equal the total time, which is 3 hours. And then from here, all we have to do is solve the equation. Again, this isn't too bad for substitution, but I think this is really just too good to pass up here for elimination. So I'm going to make this a negative 4x minus 4y is equal to negative 12. And I'm just going to solve this right off the bat here. And I'm going to add these two rows together. So the negative 4x and the 4x should cancel, so the x's are gone. 12 minus 4 is going to give me 8y, and 20 minus 12 should be 8. So we just found that y equals 1. And again, if you don't know what that means, go back to your let statement. Y is the time spent riding. So we know that they rode their bikes for 1 hour. Okay, so we know that that's one thing that happened here. However, what we really want is the time they spent walking. It doesn't ask us for both of them here. We're only really interested in the time spent walking. So let's try to find that by plugging this back in. And if we plug this in, the top equation is going to be real easy. I'm sure you could probably do that in your head. But we have x plus 1 is equal to 3. And we subtract that 1 over, then we get x equals 2. Which tells me that the time spent walking, they walked, for 2 hours. And that should get us the answer to that problem. Okay? So again, when you're dealing with a problem that deals with equations that have a total, like a total amount of money, a total amount of distance, a total amount of time, or some sort of big total, it's a good idea to set that total on the right side of the equal sign and then figure out what you need on the left side with x's and y's or whatever variable you choose to use so that it equals that total. The units must always match. So if we have kilometers and kilometers, they must equal the total kilometers. If I have hours here and hours here, it must equal the total hours. You can't do something like have money plus money equal hours. Okay? So you always got to be careful with your units. And that would be one type of word problem you could run into with systems. In a later video, I'm going to talk about this type of problem where you might be comparing two variables. Okay, so if you're interested in how to do that, and they'll typically look like a problem that deals with substitution. But if you're interested in one of those, I'll do that in my next video.